Hello everyone, good day everyone. My name is Asawa Pascal, and today's tutorial we're going to be focusing on nasal drops. Now, this is coming to you from the National Fellowship of Christian Pharmacy Students. What are nasal drops? Nasal drops are liquid preparations that are meant to be administered into the nasal cavity, and they are ought to produce having the same osmotic pressure as that of the body fluid. Right? In preparation of nasal drops, we make use of different isotonizing or adjusting agents. These are agents that are used to bring our liquid preparations to the same osmotic pressure as that of our body fluid. Now, we use two methods here in calculating the amount of isotonizing agents we add into our sterile preparations or preparations that are meant to enter into the body cavity in order to prevent irritations due to difference in the osmotic pressure between the body fluid and the liquid that is being administered into the body. Now, with this method, we have sodium equivalent method, which can also be called the E value, and the freezing point depression method, which can be called the B value. Now, we're calculating for the sodium equivalent method, we make use of this formula, which, remember E value, we're trying to get the amount of sodium chloride used. Now, before that, the isotonizing agents that we use in preparing our nasal drop could be sodium chloride, it could be dextrose, could be dextrose, and any other ones that are possibly out there. But the major one we actually use are sodium chloride. So what we actually do here using this method is trying to calculate the amount of sodium chloride that we add to our solution, to our preparation, to make it isotonic with the body preparation. So, and this formula is written as this. We're talking about E method, E value method here, which is a sodium equivalent method, E value method, E value method. So it's giving us 0.9 minus concentration of drug A multiplied by E value of drug A plus concentration of drug B multiplied by E value of drug B. Now, various drugs and various excipients in the lab would have different E values for different, we have different E values for different reagents. So in certain questions, you might be given the E values of certain drugs or certain of the excipients in the prescriptions. In certain questions, you might not be given. So what you do is you go to your codex and look for the product. There you find the E values there. So this is how we use this E value method. Then for B value method, which is the freezing point depression method, we calculate the amount of isotonizing agent we are supposed to use here by using this formula here. Amount of adjusting agents we make use of 0.52 minus A all over divided by B, where A is equals to concentration of drug A multiplied by B value. Now the difference here is B value. Remember when we're talking about the sodium equivalent method, we're saying E value. So in here we multiplied by B value of drug A, B value of drug A plus concentration of drug B multiplied by B value of drug B, B value of drug B, where B is the B value of sodium chloride, where B here is the B value of sodium chloride. It's the B value of sodium chloride. Now, to illustrate how we use this we use this formula to calculate the amount of acetylizing agent we need. We have these questions here, and this question is just trying to calculate the amount of sodium chloride that is being used here. So we're just trying to focus on getting the amount of sodium chloride required to prepare this 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 preparation or this prescription. So what we are going to do is just use the B value method because you have been given the B value method here. Just like I told you, there are certain questions where your B value method are being given to you, and there are certain questions that they are not being given to you. So you have to know how to get your B values in exam. That's why your codex is allowed in exam. So over to this. Now, because this first question is has B values of various drugs used in this preparation, because they are giving us the B values here, we are going to be making use of a freezing point depression method to solve this thing, which is going to be 0.52 minus A divided by V. So what do we do? Now say 0.52. So we are trying to get the amount of sodium chloride used. That's what the question says. Determine the amount of sodium chloride required to prepare 10 ml of morphine and ATS injection. So this question is just focusing on the amount of sodium chloride used. So in subsequent questions, we are going to go into details of how to prepare the nasal drug. But first of all, I'm trying to use this method to illustrate to you how to get the amount of the acetylizing agent, which is sodium chloride, that we are going to use to prepare this thing. So we are just going to be stopping at there. So the concentration of morphine sulfate given to us is 1 gram. So we're going to say 0.52 minus 1 multiplied by the B value of this morphine sulfate, which is 0.076 multiplied by 0.0779, plus the concentration of ATS 0.06 multiplied by the value of by the B value of ATS 0.074 plus concentration of sodium metabisulfite 0.01 multiplied by the B value of sodium metabisulfite 0.386. Then now divide it by the B value of the sodium chloride, which is 0.576. So when you do this, you'll be getting 0.52 minus 0.0873 divided by 0.576. So your final answer is going to be 0.7512. 0.7512. Right? So using this same method we used here, you can calculate this question too. All you have to do is to get the B value of this ATS, which is already given in this question. I would advise you to solve it yourself. I'm going to drop the answer to that question here. So the answer to this question number 2 is going to be 0.59. 0.59. So we now get to the details of the practical aspects of this course. Next question we have here. This is where we are solving our real first practical dispensing question here. It says ephedrine hydrochloride 0.5%, chlorbutal 0.5%, sodium chloride, potency sufficient. Now this potency sufficient tells us that we need to calculate the amount of our sodium chloride that we use for this particular preparation, and we are calculating it. Now in calculation, you must look at the values you are given to be able to determine what you are calculating, what method you are using for your calculation. Because you are given this E value method here, which is our sodium chloride equivalent method, we're going to be using this E value here to determine the amount of sodium chloride we're going to be using here. But before that, I must say that this preparation is a liquid preparation, right? And for liquid preparations, we must For liquid preparations, we must tar our bottle first. Now, for this preparation, it says make isotonic nasal drops. Send 10 ml. Send tell me. So we are sending tell me. So before anything, you must tar your bottle at 10 ml, right? Okay. So let's start by calculating our amount of sodium chloride for this question. The amount of sodium chloride using the e-value method is going to be 0.9, sorry, 0.9 minus the concentration of ephedrine hydrochloride, which is 0.5 multiplied by the e-value of ephedrine hydrochloride, which is 0.29 plus 0.5 multiplied by 0.24. So when we do this, we're going to be having 0.9 minus 0.265 to give us 0.635%. Now I must note that in getting this amount of our ionizing agents, you must expect it in percentage, right? So you expect it in percentage 0.653. So with this, we now come to get our working formula. Now, but before then, we must get our multiplication factor because this is a liquid relation. So the multiplication factor, we're told to send 10. A multiplication factor is amount sent over amount given, which is 10 divided by 100, which is 0.1. Now, remember that multiplication factor does not have units. So our working formula is going to be for this ephedrine hydrochloride, we are going to be multiplying our concentration, which is 0.5% multiplied by 0.1, which gives us 0.05% for clobutol, 0.5% multiplied by 0.1, which gives us the same 0.05%. Now for sodium chloride, we're going to be using the value we got here, which was 0.635%. 0.635% multiplied by 0.1, which gives us 0.0635%. 0.06635%. Now, this is what we are going to be using. And for water to 100 multiplied by 0.1, 10 ml. There's no surprise about that. Now, for these preparations, now in the lab, the ephedrine hydrochloride is given to you in concentrations in the lab. It's given as concentration in the lab. You might see an ephedrine hydrochloride 5% in the lab, it might be 10%. So whatever percentage is given to you. So for this preparation, we're going to be assuming that what was given to us was 5%. So if we have ephedrine hydrochloride as 5%, it means that 5 grams of ephedrine hydrochloride is contained in 100 ml. So 0.05, which is what we have percent gram here, is contained in X ml. So X ml here, when we multiply this, we have 1 ml. That means we have 1 ml of ephedrine hydrochloride. Okay, 1 ml of ephedrine hydrochloride. Now, because to save time, we are not going to be doing the same thing for clobutol because it's the same concentration. Assuming it's the same concentration of clobutol, 5% of clobutol that was also given in the lab, we're also going to be taking 1 ml of clobutol. Remember, we're taking 1 ml of ephedrine hydrochloride and 1 ml of clobutol. Now, for the sodium chloride, assuming you are given a concentration of it also in 5%, we're now going to say 5 gram is in 100, 5 gram of sodium chloride is in 100 million. Then 0.0635 is in how many mil? So when you cross multiply that, you'll be getting 1.3 mil. 1.3 mil. So this is our working formula. 1.3 mil. So this is our working formula. What you then do is now to measure out 1 mil of ephedrine hydrochloride into your already tarred dispensing bottle, 1 mil of your clobutol into your already tarred bottle, and 1.3 ml of sodium chloride or 5% sodium chloride into your ready towel bottle. You must make note of the concentration of these liquids that are given to you in the lab. You must take note of these concentrations that are given to you. Last 1.3 ml into the dispensing bottle. Then purified water was now used to make it up to 10 ml solution. So you write out your label. Your label is partly the same way with what you've been doing since. So for that, that's the end of this video.